Start now.
Hi guys, good evening. Welcome back to Wings Training Solution topic on problems on train second part. So in my last session, we discussed about the concepts regarding problems on trains and we solved exactly 4 problems regarding the problems on train, the basic things. Till third concept we solved, isn't it? Let me revise those concepts so that you will feel comfortable regarding those things. Now, mainly we have discussed 4 formulas. The first formula, like a person or tree or pole or object with a negligible length is there. Then what is the time taken by the train to cross the person? So T equal to L divided by X, where L represents length of the train divided by speed of the train. Isn't it? Done. Now, second case is instead of van, they had given platform or tunnel or bridge or object having a certain length. Now, time t is given by length of the train plus length of the platform divided by speed of the train. Done. Now, similarly, third case, t equal to L1 plus L2 divided by x plus y. Sir, what is this, sir? Very simple thing. Still, if you can remember this thing, this is called when two trains are traveling in opposite direction. Length of train 1 plus length of train 2 divided by speed of train 1 plus speed of train 2. And finally, another case at last, t equal to L1 plus L2 divided by x minus y when two trains are traveling in same direction. Same thing. Length of train 1 plus length of train 2 divided by difference of their speeds. Done. And I said clearly in my last session, instead of second train, a man is sitting inside the second train. If that is the case, you have to take the train length of second train as 0. Why? Because a man is sitting inside the train, right? They will gonna give question clearly that the first train crossed the person, the first train crossed the man who is sitting in the train too. Then we need to take second part as 0. I mean to say that wherever the man is sitting inside the train, it might be first train or it might be second train, we should not consider that length. Yes. And moreover, important thing that is that you have to remember is conversion. 1 kilometer per hour equal to 5 divided by 18 meters per second. Regarding the concept of problems on trains, the denominator part always you need to change this one. Clear. Let me continue with the case 4 problem. The first one of today's session. Two trains, 200 meters and 150 meters long, are running on parallel rails at the rate of 40 kilometers per hour and 45 kilometers per hour respectively. Now look at here. They had given one train length that is 200 meters and the speed of the train is 40 kilometers per hour. Okay. And second train length they had given 150 meters and the speed is 45 kilometers per hour. 5 kilometers extra respectively. Done. In this case, they haven't mentioned that as a same direction or opposite direction. They said parallel rails. It might be same direction or it might be opposite direction. So the possibility is there. Done. Let me complete this question so that I'll get to know that whether it is same or different. In how much time will they cross each other if they are running in the same direction? Here they had given clearly that both are running in same direction. Yes, and they had given options like 60, 100, 250 to none of these. Dangerous option, last option. Let me solve this question. Now we already know that this is comes under case number 4, that is nothing but t equal to L1 plus L2 divided by x minus y, isn't it? Now what is length of train 1, 200 meters? What is length of train 2, 150 meters divided by what is speed of train 1? 40. What is speed of train 2? 45. Sir, if I substitute 40 and 45 in the below equation, below expression, now I will get negative value, sir. Speed is always positive, no, sir. If that is the case, make sure that maximum value minus minimum value. Otherwise, simply take modulus. Done. Again, conversion is required here. 5 divided by 18. 350 divided by, I meant to say that this 18 will go to numerator into 18 divided by 45 minus 40, which is equal to 5 into 5. Done. 5 ones are 5 sevens are 35, 0. 5 table. 5 ones are 5, 14s are. Now 14 into 18. 2, 1, 14, 25. Done. 252 seconds. So the correct answer is 252 seconds. Very simple. The only thing is you should be very good at the calculation part, the simplification part. Nothing else. Apart from that, nothing else. Very simple thing. Done. Similarly, we'll see one more problem regarding the same direction concept. Yes. Two trains of equal length are running or parallelized in the same direction. Super. Same formula. At 40 kilometers per hour and 30 kilometers per hour. The faster train passes the slower train in 36 seconds. Now the thing they had given is time taken by the two trains to completely cross each other is given by 36 seconds. Here clearly they mentioned that the faster train crossed the slower train. Exactly, it had taken 36 seconds. I mean to say that the rear end of the faster train is on the same line with engine of the second train. Clear. So indirectly the faster train moving forward, okay, it exactly crossed the slower train. Now if that is the case, the length of each train is the question they're asking is what is the length of the each train? Obviously, we expected they're gonna give in terms of meters only. Yes. Let me write the formula. We already know that T equal to L1 plus L2 divided by X minus Y. Isn't it? Now, what is the value T they had given? 36, which is equal to equal length, right? Now, what I'm gonna do is I'll just assume that L plus L. So length of each train is L meters divided by X minus Y. I mean to say that first one is 40, second one is 30. But conversion is required, no. So 5 divided by 18. Now 36 into, I'll just move the entire denominator part on left hand side. Otherwise, I'll do one thing. Let me write one more step. 36 equal to 2L divided by 10 into 5 divided by 18. So, okay, 36 equal to 2L into 18 divided by 10 into 5. I'll move entire thing on the left hand side. So 36 into 10 into 5 divided by 2 into 18, which is equal to L. I'm not at all simplifying in the intermediate part. I'm not at all interested to simplify in the intermediate part. Let me simplify at last. That's the reason I just wrote each and every element. I mean to say each and every number precisely. Done. 18 into 2, which is equal to 36. Gone. Now 10 into 5, which is equal to 50. That implies L equal to 15 meters. See, that's up to you guys. However, you want to reduce these fractions, you can proceed it. See, you can do it here itself. You can do it here itself. Or you can do it here also. No problem. Nobody is stopping you. Wherever you feel comfortable, you just cancel it properly. So I'm interested to cancel at last. That's the reason I just wrote each and every element at last. Done. So this is about the same direction. Okay. Let me take you to next level. Yes. Two stations A and B are 110 kilometers apart on a straight line. So both are, I mean, the distance between stations A and B is 110 kilometers. They are on the single line. Okay, only one track. I would like to say only one track. One train starts from A at 7 a.m. One train starts from A at 7 a.m. Done. So from station a train is leaving exactly at 7 a.m. and travel towards B obviously at 20 kilometers per hour. Done. So speed of the particular train from A is 20 kilometers per hour. Cool. Another train starts from B at 8 a.m. and travel towards A at a speed of 25 kilometers per hour. So after 1 hour, another train is leaving from station B and travel towards A as usual. Speed 5 kilometers extra when compared to train from A. At what time will they meet? Definitely they will meet at some point. So now the question they're asking is at what time they will meet? Is it 10 a.m. or 10:30 a.m. or 11:50 a.m.? Again, dangerous option, none of this. Yes. Let me teach you this problem in different methods of 3 methods. So the first method also. How to solve these kind of questions? By using the first method. Okay. So let me draw the diagram. I won't say this is the easiest method, but for your better understanding only I'm trying. Oh, it's a straight line, right? And okay, just forgive me. It's not a straight line. Just assume that it's a straight line. A and B stations. So they said A 7 a.m. 20 kilometers per hour. Then from B 8 a.m. 25 kilometers per hour. And they had given the distance between A and B 110 kilometers. Done. Yes. Now look at here. 20 is there, 25 is there, 7 a.m. is there, 8 a.m. is there, distance is 130 kilometers. Now, if I want to write find out the value of time t equal to, yes, distance divided by speed. Now, distance is how much? 110 kilometers. Divided by speed is how much? 20 plus 25, which is equal to 110 divided by 45, which is equal to, yes, 5 nines are, 5 twos are, 5 twos are, 22 divided by 9, which is equal to 9 twos are 18, 4 carry, 4 by 9 hours. Let us assume that approximately 2 hours. See, this is not the correct way to solve this problem. Just for time being, I'm saying 2 hours, right? I mean to say that from 7 a.m., if I had taken after 2 hours, they will meet at exactly at some point. I mean to say that 7 a.m. plus 2 equal to 9 a.m. From station A, exactly at 9 a.m., the two trains meet each other. Or if I had taken with respect to 8 a.m., 8 a.m. plus 2 hours, which is nothing but 10 a.m. 10 a.m. I mean to say that from station B, exactly at 10 a.m., the two trains will meet each other. Okay. Now, which time I have to take? Sir, very simple, sir. In the option they had given only 10 a.m., take 10 a.m., sir. No, I should not take like that. Why? Because they had given none of this also. Why 9 a.m. is wrong? Why 10 a.m. is only correct? I should not take like that. It might be 9 a.m. also possibility is there. Okay. Now the thing is here, whatever you did, I did from 110 divided by 20 plus 25. This entire part is wrong. No, we should not do like this. Why? Because relative speed will be applicable. Only the timings are same. So when time is constant only, we can apply relative motion of objects, objects concept. Otherwise, we should not say. If you can apply like this, you're gonna get two different timing center. Isn't it? Getting it or not? Getting it or not? I mean to say that the time has to be definitely same, whether you can take with reference to 7 a.m. or with reference to 10 a.m. Anytime you can take, but make sure that you have to take in a constant time pay. Now, what I'm gonna do is from station A exactly at 8 a.m. I mean to say that after 1 hour. So train A covered 20 kilometers. Now again here you may have a doubt. Sir, how you get to know that that is 20 kilometers only? Whether you traveled in the train, sir? No, I did not. The meaning of 20 kilometers per hour is in 1 hour it will gonna travel 20 kilometers. So this is the meaning of speed. 20 kilometers per hour means in 1 hour it will gonna travel 20 kilometers. Clear. Now distance will reduce, right? Distance will reduce. So from 110 kilometers to it will reduce 20 kilometers. Subtraction. So 90 kilometers. So from 110 to it is reduced to 90 kilometers. Now I can apply relative motion of objects concept. So distance is 90, speed is divided by 20 plus 25, which is equal to 90 divided by 45. That is nothing but 2 hours. So with reference to 8 a.m., after 2 hours, the two trains meet each other. So 8 a.m. plus 2, which is equal to 10 a.m. Sir, I already told you, sir, 10 a.m. Yes, it's true, 10 a.m. Yeah. So we can solve this problem. I won't say that this is the easiest way. Okay, so the understanding way, this is what we can actually. Okay, let me teach you the second methodology so that you feel comfortable to solve these kind of questions. But my suggestion is either you can go for the second methodology or third methodology. That both are same, second and third. Yes, let's see here. Let us assume that the two trains meet X hours after 7 a.m. So I am taking the reference as the time reference as 7 a.m. I am taking time reference as 7 a.m. So after X hours, the two trains will meet. Now, distance traveled by A in X hours equal to We already know that distance equal to speed into time, 20 into x, isn't it? Speed equal to 20 kilometers per hour and time equal to x also. So 20 into x. Done. Now, the second train I need to take. See, here they had given 8 a.m. Okay, but I'm taking reference as 7 a.m. right? I have to go back exactly 1 hour. I have to go back exactly 1 hour, which is not possible. So, okay, so logically, I'm just doing this problem like this, but practically it is not possible. See, train is starting at 8 a.m. Do you know that 7 a.m. also it travel with the same speed? No, we don't know, but logically we can go ahead like this also. Okay, so 25 into x minus 1. Clear. Now they only given the total distance equal to 110 kilometers. Correct? No. Yeah. Now, what is the total distance? Distance covered by A and distance covered by B should be equal to 110 meters. See, both has to cover, right? Then only it will be 110 kilometers and they will meet it. That is nothing but 20x plus 25 into x minus 1. So, further we can simplify this one as that implies 20x plus 25x minus 25 equal to 110. So this can be written as 45x equal to 110 plus 25, which is equal to 135. Now x equal to 135 divided by 45, which is equal to 3 hours. From what time? 7 a.m. Isn't it? That means 7 a.m. plus 3 hours equal to 10 a.m. Is it the easiest way or not? Very simple. Whatever the timing they had given, just follow like this only. This is the one of the easiest way to solve this kind of problems. Then my suggestion is this one. Then here you may have a doubt. Sir, you had taken 7 a.m. as reference time, sir. What if I had taken reference as 8 a.m., sir? Correct? No. That is method 3. If I had taken reference as 8 a.m. Now, if that is the case, the second, I mean, the first part is then no from station A. This is starting at 7 a.m. right? I have to take that after 1 hour. What will happen? Okay, so let me start from station B. Distance covered by A in x plus 1 hours. Okay, 20 into x plus 1. That's true. Yeah, distance covered by B in x hours equal to 25x, isn't it? That, and we already know distance equal to 110 kilometers. That is 20 into x plus 1 plus 25x equal to 110. Same as usual, similar to previous one. So after simplification, you're going to get x equal to 2 hours. So from what time? 8 a.m. 8 plus 2, which is equal to 10 a.m. Exactly. There is no doubt in that. So whatever the method that you feel comfortable, please go through it. Nobody is stopping. Okay. Next one. We'll see one more interesting question. A man sitting in a train which is traveling at 50 kilometers per hour observes that's a goods train. He doesn't have any work traveling in opposite direction. Takes 9 seconds to pass him. If the goods train is 280 meters long, find its speed. So its speed in the sense we have to find the speed of goods train. Yes, I expected. Definitely they're gonna give in terms of kilometers per hour. Yes. Now look at here, guys. A man is sitting in a train which is traveling at 50 kilometers per hour. So speed of train they had given. I mean to say the speed of man also they had given. That is 50 kilometers per hour. And which direction? Opposite direction. That we know that t equal to L1 plus L2 divided by x plus 5. First of all, we have to write this part. Case 3. Now time taken is 9 seconds. 9 equal to now what is length of train 1? We should not consider length of train 1. Why? Because man is sitting inside the train 1. So we should not consider actually. Okay. So this becomes 0. What is length of train 2? I mean to say that goods train they had even 280 meters. Divided by speed of train 1 is 50. Speed of train 2 is we don't know. That is what we need to find. So 9 equal to 280 divided by 50 plus 5. So 50 plus y equal to 280 divided by 9. See, numerator is in terms of meters and denominator is in terms of seconds. So conversion is required. So into 5 divided by 18, we need to multiply. 5 divided by 18 into 5 divided by, I'm sorry, really sorry. 18 divided by 5. Why? Because you are converting meters per second to kilometers per hour. Then 9 ones are 9 twos are 5 ones are 5 fives are 25, 5 six are 20. Now 56 into 2, 112. 112. Now y equal to 112 minus 50, which is equal to 62 kilometers per hour. So this is how we need to solve the problem. Simple. Somewhat. Some tricky. Yeah. Next problem. A train running at 54 kilometers per hour takes 20 seconds to pass a platform. Okay, platform is nothing but case 2. Next, it takes 12 seconds to pass a man walking at 6 kilometers per hour in the same direction. Okay, this is case 4 in which the train is going. Okay, now case 4, why did I say that? Because now man is walking. That means obviously length I should not consider in terms of man. Length is 0. Find the length of the train and length of the platform. So, yes, we need to find what is the length of the train and we need to find what is the length of the platform. They had given that in meters. Yes. Let me write the first condition. That is platform case. See, we already know that time taken by the train to completely cross the platform is given by t equal to L1 plus L2 divided by x, where L1 represents length of the train. Length of the train, isn't it? L2 represents length of the platform. Then, first of all, we don't know those values of length of train and length of platform. Then, time, how much they had given? 20 seconds. L1 plus L2, we don't know. Just write it down like this. Speed, how much they had given? 54 kilometers per hour. So, conversion is required. Now, L1 plus L2 equal to 20 into 54 into 5 divided by 18. So 18 ones are 18 threes are 5 threes are 15, 15 into 2 30, 30 0. So 300 meters. Now L1 plus L2 equal to 300 meters. So sum of their lengths equal to 300. Let me assume this is equation. See, I can easily eliminate first option. Why? Because 100 plus 120 equal to 220, but I need to get 300. 160 plus 140, 300. Possibility is there. 150 plus 200, no, not at all possible. None. Dangerous option, none is there. If instead of none, if they had given some other value which is not equal to 300, I can mark blindly second option is the correct answer. Okay, so we have some but excuse me, same direction. Now t equal to L1 plus L2 divided by x minus 1. Clear. Now what is the time they had given? 12 seconds, which is equal to, now look at here, L1 represents first train, train 1. L2 represents man, length of train 1 and man length. So length of train 1, I don't know L1. What is man length? 0. Now x, how much value they had given? 54. 54 minus y. Why they had given? I think 6 kilo. Yes, yeah, 6 kilometers per hour they had given. Conversion is required into 5 divided by 18. Yeah, let me take to next slide. So 12 equal to L1 divided by 48 into 5 divided by 18. 54 minus 6 is 48. Now that implies L1 equal to 12 into 48 into 5 divided by 18. Then 6 threes are 18, 6 twos are 12. 3 ones are 3 ones are 3 six are. Yeah, 16 twos are 3, I mean 32, 32 into 5, 160. Therefore, L1 equal to 160 meters. I know L1 equal to 160 meters. Now L2 equal to 300 minus 160, which is equal to 140 meters. This is the we need to solve this problem. Clear. So the correct answer is second option, 160 meters and 140 meters. Next one. Yeah, one more interesting problem. A man in a train notices that he can count 21 telephone posts in 1 minute. He can count 21. Straight thinking. If they are known to be 15 meters apart. Oh, okay. Somewhat distance is yeah less. Then the speed of the train traveling is. Now the question they are asking is what is the speed of the train? Okay. Let me explain a simple concept here. See, the meaning of apart we already know. Apart means distance between first telephone post and second telephone post is 50 meters. Let me take the first scenario. First scenario. If I had taken two telephone post one, telephone post two. So what is the distance here? 50 meters. Correct? No. Now if I had taken two telephone post, distance is 50 meters. Done. Now let me take three telephone posts. 1, 2, 3. Telephone post 1, telephone post 2, telephone post 3. So 50. Okay, let me write it here. 50, 50, and 50. I'm sorry, 250. So total 50 plus 50, 100. Yes, 100 meters. Yeah. So if I had taken three telephone post, distance is 100 meters. Done. Yes. Let me take another scenario. So third scenario, if I had taken five telephone post, five telephone post one, two, three, four, five. So 50 and 50, 50, 50. So totally how much are you gonna get? 200. Isn't it? 200. Here there is a logic. Sir, next thing you will draw 21 telephone posts, sir. No, I won't draw 21 telephone posts. Why I should draw? Waste of time. Waste of time. Okay. So what I'm gonna do is I'll make it comfortable, easiest way to get to the shortcut. Now, if I had taken two telephone posts, I'm getting 50. So what I have to do is when there is a value called, when they had given two telephone posts, I have to take one less than 50 into 1, 50 into 1, which is equal to 50. Now, if they had given three telephone posts, right, I have to reduce one. That means two telephone posts into 50, which is equal to 100, isn't it? Now there are the five telephone posts, right? Instead of five, I have to take only four. So 4 into 50, which is equal to 200. So this is the logic. Now 21 telephone posts, right? Instead of 21 telephone posts are there. Now the distance is that is given by 20 into 50, which is equal to 1000. This is how we need to do it. Yeah. Clear. So total distance equal to 20 to 50. To explain why we are writing 20, because of the 20, I have to explain this things. 1000 meters. 1000 meters. So this 1000 meters can be written as 1 kilometer. Second part, time they had given. How much they had given? 1 minute. So time equal to 1 minute. So I'm converting this one in terms of hours. 1 minute equal to 1 by 60 hours. 1 minute equal to 1 by 60 hours. Sir, why you are converting, sir? Why? Because the option they had given in terms of kilometers per hour. No, because of the 2D conversion is required. Therefore, speed equal to distance divided by time. Distance divided by time, that is nothing but 1 divided by 1 by 60, which is equal to 60 kilometers per hour. Yeah, very simple. 60 kilometers per hour. Here. So here, luckily we got none of this is the correct answer. Yeah. Next one. Two trains running in opposite directions crosses a man standing on the platform in 27 seconds and 17 seconds respectively. So two different times trains actually. They cross each other in 23 seconds. The ratio of their speeds is, yeah, very, very important, guys. A couple of examination, the same question they had given. Okay, still they're giving the same question. Important thing, the confusion ratio. This is standard question. Standard question. Okay. Now, what exactly they mentioned is, so opposite directions. Two trains are traveling in opposite directions. One thing they had given is 27 seconds. I mean, processor map. And second thing they had given is 17 seconds. I mean, another train processor man, 17 seconds. So this case is comes under, yes, which case? First case, a train crossing a man. Done. Now this 23 seconds they had given, no, this one is comes under case 3, that is opposite direction case. Let me write each and everything step by step. Okay. Let me write first case. Now regarding first train, now T equal to L divided by X, length of the train divided by speed of the train. Now what I'm gonna do is I'm gonna make it T1. Now T1 equal to L1 divided by X. L1 divided by X. I mean to say that first train is traveling with the speed X kilometers per hour, and the first train length is L1. The time taken is 27 seconds. So 27 equal to L1 divided by X. Isn't it? That implies L1 equal to 27x. Then I got first equation. Now let me write second equation. Now T2 equal to L2 divided by y. I mean to say that second train is crossing. I assume that second train speed is y kilometers per hour or y meters per second. L2 length of the second train, and T2 they had given as 17 seconds. 17 equal to L2 divided by y. That implies L2 equal to 17y. Here, done. First case and second case is completed. I mean to say that first train and second train completed. Now coming to the third part. Okay, they cross each other running in opposite direction. Now T equal to L1 plus L2 divided by X plus y. X plus y. Now what is T they had given? 23. 23 equal to, see, L1 we already know, that is 27x, plus L2 also we already know, 17y divided by X plus y. Now what I'm gonna do is, the denominator part is there. Now I'm gonna take on the left hand side. Let me solve this thing in next slide. Now 23 into x plus y, which is equal to 27x plus 17y. Yes, correct. Now 23x plus 23y equal to 27x plus 17y. Take y on left hand side, x on right hand side. 23y 17y equal to 27x minus 23x. Now here it is 6y equal to 4x. Now 4x equal to 6y, x by y equal to 6 by 4. Nothing but 2 3s are 2 2s are. Therefore, x is to y equal to 3 is to 2. That's it. Very, very important thing. 3 is to 2 is the correct answer. Yeah. Clear. The most important problem, you should be very careful while looking at these things. You can spend a lot of time in the examination because this is a standard question. A couple of examinations they ask the same question. Okay, so regularly they'll ask the same question in TCS. TCS repeated question, even in quizzes also. Yes, the next one, interesting part. A train leaves Chennai at 5 a.m. Okay, and reaches Bangalore at 3 p.m. So early morning it will gonna leave and it reaches in the afternoon. Another train leaves Bangalore at 7 a.m. Okay, after sunrise, and reaches Chennai at 5 p.m. in the evening, sunset. When do the two trains meet? Definitely they'll meet. Assume that the trains travel at equal uniform speeds. That is important. It has to travel with equal uniform speeds or different speed. They have to mention. If it is different, the answer will be different. If it is equal, the answer also will be different. Now, what I'm gonna do is I'm gonna solve this problem in a logical way. Instead of the problem, I mean, by using the formula way, let me solve this question in a diagrammatic way, the logical way. So they had even two stations. That is, one is Chennai, other one is Bangalore. Okay. So the first train starting time from Chennai is at 5 a.m. Done. I just gonna divide in terms of 1 hour interval. I mean to say that 5 a.m., 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10, 11, 12, 1, 2, 3 p.m. Done. Next, another train they had given Bangalore, Chennai. So starting time is 7 a.m., ending time is 5 p.m. Now, if you can observe these two graphs, I mean to say that two timelines. So there will be a common time. Okay, the common time is nothing but exactly at 11. So these two trains meet exactly at 11 a.m. 11 a.m. Clear. Now, one person is asking like this, Sir, if we can gonna see two timelines, sir, there is one more possibility also is there, sir. Now I was wondered, how come one more possibility is there? Those two trains will meet exactly at only one time only, no. But the student is saying that one more possibility also is there. I mean to say that it will gonna meet one more time. Sir, look at here, sir. 5 and 5 common, no, sir. Yeah, 5 and 5 common here. Now the problem is, buddy, this is exactly 5 a.m. and this is exactly at 5 p.m. Never be common. Never be common. 5 a.m. is not at all equal to 5 p.m. Even though the numbers are same, it doesn't mean that definitely it has to be equal 5 a.m. and 5 p.m. No, it won't. Until and unless it has to do some time travel. Okay. So the correct answer is 11 a.m. is the correct answer. 5 p.m. or 5 a.m. is absolutely wrong. Even though the times are common, but a.m. and p.m. cannot be the same. Okay, so that's all about regarding the second part on problems on trains. Hope it was clear for everyone. Okay, now still if you are finding difficulty regarding problems on train, on any question, just drop me a message in the comment box so that I will gonna give clarification regarding the particular question regarding problems and trials. So please like and subscribe to our channel. So as well as the video. So please drop a comment if you feel whatever you want to mention regarding the video. If you have a doubt, if you have anything apart from that, why we solve this methodology only? Why can't we solve this methodology? Can we try the same problem in another way and all? Whatever the doubts that you have, you can just drop a message in the comment box. Yeah. Thank you. Thanks a lot. Okay, we'll come up with another video. Okay.